Hello everyone, welcome to another Teach to Code with Professor V, the Python edition. So, like always, I already have my Jupyter notebook open. The last one we did was the print sine of pi over 4 all the way to 4 pi over 4. Now, what I did here is I copied and pasted some of the problems. I said we were going to work on the height of a tree, right? So that was going to be the first one we were looking at. Let me go ahead and go to the book. So, I pasted a couple of them that I would be working with, so that way I didn't have to kind of go back and forth on the book. But if you guys see the questions, right, this is question 03.34. So, I did skip some of them, 3.6, 3.7. I was just trying to record this first problem and was already having issues, so, for whatever reason, it does seem like sine and tangent and all these things work better with radians. So let's go ahead and get started. The U.S. Forest Service can use trigonometry to find the height of trees. The height of a tree H is equal to the distance D between an observer and the base of the tree multiplied by the tangent of the angle theta. Between looking straight along the ground and looking up at the top of the tree to the formula H is equal to D tangent of theta. If a Forest Service ranger is 20 feet away from the base of a Douglas fir tree and looks up at a 63-degree angle relative to straight ahead to see the top of the tree, what is the height of the Douglas fir tree? So, we do have a couple things here, right? So let's go ahead and start it. So from math, import, I'm just going to do star because I forget if it's just tan or tangent that we need to import. So yeah, there's a couple ways we could go about this. I guess we could just set a variable. So height h, right, is equal to the distance, which is 20, times tangent. And the problem I was having here is I can't just pass in 63 for whatever reason. I tried putting like degrees to radians and the radians to degrees. I tried to do it a couple of different ways, but it just didn't seem to be working out for me. So what I went ahead and did is I times this by pi and divided it by 180. So if you don't remember how to convert something to a radian yourself, right? Well, it becomes 63 times pi, right? So 63 degrees over 180 degrees means that the degrees are going to cancel each other out, right? And that really is the conversion right there. That's what turns it into radians. So for whatever reason, I wasn't getting the right answer until I did this conversion, which the height of the tree is about 39.25 feet. So, and I have my proof right here, tangent of 63 times 20. So I also did it in math way over here. So I was looking for different forms to really make sure that I was doing the proper thing. If you guys can find a way to do this a little bit simpler, that would be nice. I don't feel like we should have to be converting for Python, but for whatever reason, that's how the answer came out right. So anyway, what can we do, right? So here we have Q03.36 or question 3.36. A simple model of water level based on tides, assuming high tide is at midnight, is H is equal to 4.8 times sine of pi over 6 times t plus 3 plus 5.1, where h is the water height and t is the number of hours since midnight. Using this model, calculate the water level h at 6 a.m. T is equal to 6 hours since midnight. So all we really have to do is plug in t equals 6 to this big equation, right? So again, we'll go ahead and start from math, import star. We'll give ourselves a variable to store our value. So here it's going to be 4.8 times sine, since it's pi over 6, this should be a good calculation. I can go into the whatchamacallit, the Mathway or something, or calculator, and just kind of prove it to ourselves, right? So since t plus 3 is in parentheses there, we're going to want to put that quantity in parentheses. That way we make sure the order of operation adds this first. And then we'll simply go ahead and put h down here. So 26.69. So we can definitely try this if you guys would like, but I think for the most part we can trust this. It's since it's a radian, I feel good about it. Whenever we're inputting degrees, it seems like we're gonna have to do some extra math to our stuff. So the water level will be 26. I don't know. Did they even give us units for this? They didn't even give us units. So the water level's height will be 26.69. Yeah, they did not give us units. Huh? What a funny problem. The teachers would be mad at them, right? So anyways, that's how we could calculate this one. So, don't get too tricked up with the signs and all the extra math. So now question 3.37. The x component of a force f of x is equal to the magnitude of the force multiplied by the cosine of an angle theta of the force relative to the positive x-axis. So f of x is equal to the force cosine of theta. Well, the magnitude of the force, sorry. The magnitude of the force times cosine theta. If the magnitude of the force is equal to 12.4 and the force acts at a theta is equal to 110 degrees relative to the positive x-axis, what is the x component of the force f of x? So, it sounds like a lot to do, right? When we're working with physics and stuff. I'm not too sure why they chose to do such robust problems in the first chapter. Now I'm kind of seeing how my tutorees are having some trouble with some of this. But anyway, so we do have the magnitude of the force, which is 12.4. That goes, oops. Let me go ahead and hit run on this cell. So that goes here. And then we have times the cosine of 110 degrees. So we could simply call this f of x, the force of x, right, is equal to the magnitude, which is 12.4, the magnitude of the force, times, and it's cosine that we're using here. So it is 110 degrees, so what I'm going to do is times it by pi and divide it by 180 to make sure that I'm in radians, because for whatever reason I was having issues, so I trust my formula now that I've gotten it down. So the x component is actually going to be negative in this case. That's pretty interesting. Let's see what we have. So 12.4. So I feel like I should probably check on this one. So let's go ahead and try it. So let's do 110. Let's find the cosine real quick. So it's negative 0.34. So our answer will be negative. So that's good. 12.4. So negative 4210. Cool, perfect. So just double checking, right? So it's probably some kind of downward slope or something, huh? Yeah, because this is the x component. So yeah, it's probably some downward slope where we're actually sliding downward. Which does make sense, right? If your initial x was up high and you're sliding down, you're actually at a negative x, right? So It does make sense. The slope's probably a negative slope going in this direction if y'all are following my mouse. I know I'm not drawing it, but this isn't exactly a physics class either, so, if you guys want some more details, maybe I could jump into it and draw some pictures and stuff. But anyways, so question 3.37. The distance of a free thrown projectile is dependent on the projectile's initial velocity via zero. There's some typo there. The acceleration due to gravity, g, is equal to 9.81 meters per second squared, and the angle theta, at which the shouldn't it be projectile is launched according to d is equal to, man, I can't even read this. It translated it kind of weird, if you ask me. Let me go find the actual problem. If the projectile, where was I at? See, dear Lord, is launched according to, okay, so I'm on the actual, so d is equal to v is 0 squared divided by g sine of 20. If the projectile is launched at a 12th degree angle with an initial velocity of 150 meters per second, how far will the projectile travel? So we do have this little formula here. Let me see how it looks in the Jupyter notebook. Oh yeah, it came out very horrible. That's what's going on. That's v sub 0. Okay. Yeah, it didn't come out right, so maybe my thinking wasn't going to work. It's okay. So anyways, so from math, import, star. Sometimes we try to make things in life easier, right? But it doesn't turn out that way. So let's see what we do have. We have v of 0 squared over g. So let's go ahead and put this in a bracket. So we have 150 squared, and then that would be divided by g, right? Or am I already off on this one? Yeah, okay. Next, after we find out that ratio, what we're going to do is times by sine, and it's 12 degrees, so since it's degrees again, I want to turn this into radians by timesing by pi and dividing by 180, because it's just what's working, I don't know. How weird that they put, oh, it's 2 times theta. Okay. I was like, why do they have that there? So, alright. So it's 2 theta inside of the sine. So if we go back to this, it's 2 theta, right? Not 20. So it's 2 times theta's inside of the angle. Now, I don't know if it'll really affect the answer. We can put this in another bracket if we desire. I feel like maybe we should, just to be safe. And what we get is 932. So this projectile will travel 932 meters, I believe, right? Because we're calculating a distance at this point. Now we can get out the calculator and make sure that, everything's going according to plan. So let's go ahead and try it. So 150 squared. And let me go ahead and hit equals. Then we divide it by gravity, which is 9.81. Okay, and then we times it by 2 times, man, see, it's gonna come out all jacked up. Alright, let's go ahead and do the sine right away. So if it's 12 degrees, it's gonna be 24, right? Let's just make life simple. So sine of 24, that's what we initially have. My calculator's set in degrees, so I trust it. Now we're gonna times, let me go ahead and put a parentheses here, 150. Let me go ahead and square that. Then it's going to be divided by 9.81. Go ahead and close my brackets. Okay, so 932.8822. Perfect. Okay, so we're getting the same answer on the calculator. Sorry. Never really like calculators too much, but you know, sometimes they're good to have. Alright, so how long are we at? 15 minutes. So, alright, these problems are taking a little longer than I thought, just because, you know, it's good to have the calculator to check we're doing things right. Alright, so question 3.42, so a little bit about logarithmics. So, logarithms turn multiplication into addition, complete both of the calculations below to see if the expressions are equal to each other. So the log of, we'll just go ahead and find it in the book. So log of 87.1 times 210 times 10 to the third can actually be rewritten as log 87.1 plus log 210 plus log 10 to the third power. So if you've ever practiced working with the logs, right, we've seen these rules happen. So anyway, if not, it's fine, you know. So let's go ahead and do from math import star. So now we're going to go ahead and do log 87.1 times 210 times 103. Now the easiest way to check if these equal each other is to make it true or false, right? To do the actual equals. So now we'll do 87.1 plus log of 210. Oh, and it shouldn't be 103, right? It was 10 to the third power. See, some of this didn't copy and paste right. Plus log to the 10 to the third power. Now let me double check it is 10 to the third. Yeah, it's 10 to the third. I just wrote 103. So let's go ahead and run this. So true. So these get the same value. You know, if you do want to like officially check it, you can I guess go ahead and do something like this, right? We can comment this one out. Oops, I meant to comment the bottom one out. If we run it, we get 16.7219 dot 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 dot. Then we can comment this one out. We should get the same value. So you see that? So when we checked with Python, it became true. Okay, let's try to keep moving forward so we can try to finish these problems off at least. So the magnitude of the vector is equal to the square root of the sum of the squares of the vector's components, Vx, Vy, and Vz. Let me go ahead and read it from the book, 3.45. Okay. So you could see the magnitude of the vector is the square root of the components, right? Vx plus Vy plus Vz, all of them squared. What is the magnitude of a vector that has the component v of x is equal to 76.3, v of y is equal to 70.9, and v of z is 93.6. So let's go ahead and just do this. So I believe we still need to import math, right? So from math, import star. We could just say v, right? Of course, we could have variables too. I guess let's go ahead and try this one as variables. So let's go ahead and do 76.3. Let's go ahead and say Vy is equal to 70.9. So this is a variable-based chapter, right? So maybe we should practice some of this. So we're going to initialize 3 variables to store our value. And then we're going to go ahead and do just v, right? V is equal to sqrt, and this will be v of x double star 2 plus v of y double star 2, so raised to the second power, plus v of z double star 2. So Then after that we just hit V, right, to give us the V value. So let's go ahead and find out what we have. So 140 would be the magnitude of our vector. So, beautiful. Alrighty, so the area of a circle A is dependent on the circle's radius according to area is equal to pi r squared. What is the area of a circle with the radius equal to r? So we do need pi, so we'll have to import math again. Import star, I'm just going to say. So here we could say r is equal to 4. And then a is equal to, well, so it's pi r squared, right? So pi times r raised to the second power, give us the area. So that should be 50 square feet roughly, right? 50.26 dot 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 dot. Alright, so the volume of a sphere V is dependent on the sphere's radius. R, according to V, is equal to, I believe that's 4/3, right? Pi r cubed. Let's double check. Yeah, 4/3 pi r cubed. So that's the volume of the sphere. Okay. So we'll pretty much copy what we did on the other problem, right? We're going to change the formula we're using a little bit, but let's go ahead and just do an r real quick. So r is equal to 1.5, that'll be our radius. So we could say volume is equal to 4 divided by 3 times pi times r to the third power. And let's go ahead and give us the V value, the volume. So the volume would roughly be 14. Did they tell us what our units were? They didn't again, right? Cubic units, you know. Whatever the units are. So, alright. Then general equation for distance. D, that a falling body travels neglecting air resistance, is D is equal to 1/2 times G T squared, where G is gravity, T is time. G is the acceleration due to gravity, and T is the fall time. Assume the acceleration due to gravity, G is equal to 9.81. How far, what distance will a ball fall at when T is equal to 12, and time is equal to 12 seconds? So this is the problem we're looking at here. Wonder why these fractions didn't come out very clean. But anyway, so it's 1/2 G of T squared. So how many variables do we have for this one? Do we need any imports for this one? I don't think so, right? No, this is good old algebra. Okay. So here we could set G is equal to 9.81. Here we could set T is equal to 12. And then the distance is equal to 1/2 times G, right, times T raised to the second power. And then give us the distance. Alrighty. So 706.3 meters, or whatever it is that we're calculating by, because they don't give us units. So, alright, here's the last problem. Almost under 25 minutes, so that's where I want to keep them, at least 20 to 25 minutes. So let me go ahead and read it from the book. So 3.81. If there's any questions, I will try my best ability to explain any of these to you. Find it very interesting. They went very deep into some physics here. But anyway, electrical power P is related to current I and resistance R. According to an electrical load with a resistance R is equal to 10,000 running at a current I is equal to 0.200 draws how much power? So I is the current that flows, right? R is the resistance. Yeah, so I don't think we need to import anything for this one either, right? We just simply need to set an R. So our resistance is 10,000 ohms. Our current is going to draw 0.2. Oops, I should probably set that to equals to initialize my variable. And P is going to be equal to I squared times r. And then give us the power, right? Which I believe is in watts. If I'm wrong, you guys can yell at me. So 400, I believe watts. I don't think that's amps, but it might be. It's been a while since I played around with electricity. So 400 is our power. So that's how we could do some of these, Again, a lot of this might not be perfect, If there's any other problems you guys would like to see in here, if there's anything with like linear algebra or quadratics, let me know. I could definitely find something a little more, simplistic as far as math's sake. But other than that, I hope you guys enjoyed the video. Did seem to turn out to a lot, right? Just double checking the answers and stuff. But it's always good to double check, It's just good to be thorough, But you can use Python for a lot of science, right? A lot of physics, a lot of beautiful equations and proportions. So hope you guys enjoyed the video. If there's any questions, comments, how to make this better, please put them down below. Other than that, I hope you guys have a great day.